Right, question 2. A number of capacitors, each of capacitance 10 microfarad, are connected in a network between terminals X and Y as shown below. Initially, the wires crossing at point P make electrical contact. Calculate the capacitance of the network between X and Y. So really what you have there is you've got really two blocks of capacitors which are joined then, like that. And they have a capacitance of 10. So if we just work on one line here, first of all, you've got two capacitors connected in series, and they have a capacitance each of 10 microfarads. And that means across that line, because they're in series, so each line in series, the total resistance, because they're identical, is half of one of them. And so each line is 5 microfarads. So every single line here, if I write that in, I'll write it in maybe in green here. So each line has got 5 microfarads in total. So that's a whole line right across each line. Now, we'll just work with this parallel bit. First of all, two sets of capacitors in parallel with each other. To get the total capacitance, you just add them. So each block then is 5 plus 5, which gives you 10. So I'm going to write that in red then. So that whole block is 10, and that whole block is 10. They're in series with each other, and therefore, as before, when you add them in series, the answer is half of one of them, and so the answer then comes out to be total capacitance of half of 10, which is 5 microfarads, and that's your answer there. The bottom one, same circuit again, but this time it's as if they're not joined. And so this time what you have is really 4 in series with each other, and then they're in parallel with another 4, like that. Okay, so each one again has got a capacitance of 10. And so there's 4 in a row. Again, they're identical. And so if you had 4 resistors in parallel with each other, and they were identical, your total resistance would be a quarter of one of them. And therefore, so the total resistance, or the total capacitance of that entire line, is a quarter of one, which is 2.5. But again, you have the same situation here where you've got two lines in parallel with each other, and to get the total capacitance, you just add the two lines. So it's 2.5 plus 2.5. And the answer comes out again as 5 microfarads, the same as the circuit above. So it doesn't matter whether they make electrical contact or not, the total capacitance in each case is coming out there at 5 microfarads. The last question on the back of the page, the diagram below shows an arrangement of capacitors. There's a 10, a 20 and a 30. Find the total capacitance. They're in series with each other, so you're going to have to, there's no other way to do it but to add them as if they were resistors in parallel. So it's 1 over 10 plus 1 over 20 plus 1 over 30. And you have to make the common denominator 6/8. So it's 6 6/8 plus 3 6/8 plus 2. That gives you a total of 11 6/8. And then you have to turn that upside down to get your answer. So it's 60 over 11. And that gives you 5.45. And again, that's microfarads. Right, here's this question coming up again. A capacitor of capacitance 470 microfarads is charged to 80 volts. It is then disconnected from the power supply and joined in parallel with an uncharged capacitor of capacitance 1000. So we'll just draw this out here in the corner. And you've got 470 microfarads and 1000. Find the PD across the capacitors after they're joined in parallel. So the first thing you have to do, if I just draw this over here, is find the total charge that your 470 was charged to. And so you had 80 volts available and 470 microfarads. And so Q is equal to CV, and that's 470 times 80. which gives you 37,600 microcoulombs. And then to find the total capacitance, the total PD across them, you have to work out the total capacitance when they are joined over here. So they're in parallel, so you just add them. And so that gives you 1470 microfarads. And then the last thing you have to do is find your voltage. And voltage is going to be equal to Q over C. Totals, of course. And Q is 37,600. C is 1470. And that comes out as 25.6 volts. So that's a good bit lower than the 80 volts that was there initially. And you would expect that. Last part of the question, how much electrical energy is lost in this process? So what you have then is you have to find the total electrical energy beforehand and take away the total electrical energy afterwards to find how much is lost. So initially, you have E is equal to half CV squared. And beforehand, you had a capacitance of 470 and a voltage of 80. I'll just write micro in there. And that comes out as an answer of 1504 microjoules or 1.504 joules. So that was your initial 1,504,000 or 1,504,000 microjoules, or that's at 1.504 joules. And in a different colour I'll do now. So E is now equal to half CV squared again. Total capacitance is now 1470. And your total voltage is 25.6 and it's squared. And that comes out as, have I got an answer here? 0.48 joules. And so then the energy lost is equal to 1.504 minus 0.48. I'm just going to write it in this box here. And the answer is 1.023 joules is your answer. And that's the end of, that was Unit 1, Homework 1 on capacitors. This is